Derk van Veen will tell us about partitioning, going much deeper into this stuff beyond we should partition. And I heard about him that he is a very passionate chess player and organizes chess tournaments. So if you are interested, please ask him and you can play together. So, Derk van Veen.
Cool, thank you. I've been talking about partitioning now for a few years. And I know I say like leveraging table partitioning for query performance. 2 years ago, I thought query performance would be improving with partitioning. I was wrong. But if you're not messing up your partitioning, the performance is not going to be too dreadful. So that's what I hope to explain you today. And the more I do with partitioning, the more I see partitioning all around me. And you know the true masters of partitioning? It's the supermarkets. They are so good at partitioning. When I go to my local supermarket, I enter the supermarket, and it's the fresh department. There are groceries, fruits, nicely split it into 2 partitions. And then after the groceries, we have canned food. And for the canned food, they also do, how do you say this? They take care of their stock. So the things they want to sell first are in front of the shelf, and the things they can sell later are on the back of the shelf, without dropping off the stage. And I try to imagine a supermarket where there's no partitioning. Like you enter the supermarket, and you have to say, like, I need eggs, and I need, I don't know, some canned food, and you get a badge, or this list. Like eggs, yeah, maybe you can find them at row number 5, rack number 20 at the first shelf. And if not, you go to stack or path number 16, top shelf. Maybe there are some eggs. It's like, for me, that was kind of a funny thought experiment. Like an unindexed supermarket or unpartitioned supermarket. So, why do we talk about partitioning at all? I think there are 3 good reasons to do partitioning. And the first one is a really bad reason to do partitioning. Postgres has a physical limit for how much data you can store in a table. So what's the maximum amount we can store in a table?
32 gigabytes.
How many gigabytes?
32.
No, we can store more than 32 gigabytes, Boris. 32 terabytes, thank you, given the fact that you have 8K pages. If you wait until you have 32 terabytes of data in a single table, you're too late. That's not the right moment to start partitioning. I would say if your tables get to a size of roughly 100 gigabytes, that's a good moment to start thinking about partitioning because you're in time. And then you can take another 100 gigabytes of time to develop a good practice, and then by the time you get in trouble, you're actually out of trouble because you're already in good shape. The second reason to do partitioning is easier maintenance. And for me, this is the most intuitive version of explaining something. Maintaining something really big is just way harder than maintaining something small. Creating an index on 100 gigabytes is way easier than creating an index over 100 terabytes. It's just as easy as that. So maintenance is just easier with small things. It's easy as that. And then the third reason to do partitioning is data lifecycle management, just like the supermarket does. You want to know when data comes in, so you can also know when data can be archived, deleted, moved to a glacier. I don't care. But if you're collecting a lot of data, you also need to get rid of all this data. That's the third reason to do partitioning. So we have 3 types as well to do partitioning. What is the best way, the best type to do partitioning? Yeah, hash partitioning. There's always a developer who says, like, I love hash partitioning. And I was like, no. Hash partitioning is the very worst to do partitioning. I will take a stand here. It's the worst way to do partitioning. I'll tell you why. A hash is random by definition. So you're inserting your data at a random position in your table, which can be good, which can be bad. But this is also random inserts in your index structure. That's a lot of full-page inserts in your role for your indexes, generating so much raw files, and you don't want to. And then usually they say, like, yeah, but I have this 10 tables, and I can insert in all 10 partitions at the same time. And actually want to do this when they say this. I usually take a deep breath, like I do now, and I explain them. Let's say you don't care about all these random inserts, this full-page inserts in your WAL file, and you have these 10 partitions, and it works like a charm. Now you're collecting more and more data, and these 10 partitions is no longer enough, and you need to scale to 20 partitions. What do you do with the data in your original 10 partitions? You need to redistribute everything. And you are doing partitioning because you have so much data. So you have to distribute terabytes of data over your system. That's like the worst plan ever, right? So hash partitioning, if you ever run into trouble with hash partitioning, don't ask me to help you out. So what's then the right way to do partitioning? Well, the other option is list-based partitioning. And I would say list-based partitioning. I know, it's a black slide. I can just talk about things. So list partitioning doesn't really help. You can create a trivial list, a yes-no list, right? It's true or false, active or inactive. But then if you grow to 100 gigabytes for something and you split it in two, you still grow to a lot of size, and then you're in the same trouble only later in time. So list partitioning only delays the problem for a little while. So I would say list partitioning doesn't work. Then you can say like, yeah, but I want to have a list, and I have a partition for active and a partition for inactive, and I only partition all my inactive stuff. And in theory, it might work, but I'm afraid like one level of partitioning is already hard to master. I'm afraid 2 levels is a disaster, so I'm just not brave enough to try it out. And I did some brave things with partitioning, to be honest, but this one is too, I'm not going there. And then the last way is range partitioning, and gladly most of you would say range partitioning is the best way to do partitioning. And I would say it's the only correct way to do partitioning. And if you want to argue with me about it, that's perfectly fine, but I will say, and I will stick to it, it's the very best way of partitioning. And I want to spend like a few seconds on the default partition, because you can always have default partitions, and default partitions are the root of all evil when it comes to partitioning. It generates massive amount of logs. If you start using the default partition, it's almost impossible to get rid of the default partition because there's data in it, and where should it go? And it's a manual operation. The system doesn't do it for you. Default partitions, I know the concept, and I love the concept until I started using it, and then it was like the worst decision based for partitioning I ever made. So don't go there. So let's take a look at range-based partitioning. I think the most intuitive way to do it is for dates, because a date is a very intuitive way to do a partition. Let's say I just have a partition, and I collect some data at the beginning of this year. So my partition is from January 1st till February 1st. The lower boundary is included, the upper boundary is excluded. So this partition can hold all the data I can collect in 1 month. And then of course, I want some more partitions because I don't want to run out of partitions. So let's create 3. That fits nicely on my slide. And when it comes to collecting PII data, this is a really good way of collecting or storing your data. Because if it's PII data, you need to get rid of it after 3, 5, 7, 10 years, depending on where you collect it. And based on the upper boundary of your partition, it's very easy to say like, yeah, this is more than this amount of time. Also, I just dropped my partition. No cleanup job, no complicated logic. Easy does it. It's just say, hey, database, I don't need this anymore. Can you get rid of it? And easy does it. Just a simple catalog operation. Okay, the operating system still needs to get rid of all your data files, and that might mess up things, but at database level, at least it's easy. No cleanup jobs, no walls. Nice. But there is a downside to it as well, because the partitioning key has to be included in the primary key. And usually dates are not included in the primary key. We are working with relational tables. We want to join tables together. So date is maybe not the easiest way to do it. So then you go to your primary key, which is probably some integer type. And you want to partition on an integer type. So how would that look like? Well, actually, it's the same. You have a lower boundary, an upper boundary. I can collect 1,000 rows here in the first partition, but not number 1,000. Number 1,000 should go to the second one because the lower boundary is included, the upper boundary is excluded. But I can still insert 0. Don't, by the way, create partitions for 1,000 rows because you will blast through it in a millisecond. But 1,000 on my sheet just looks way more clean than 1 billion. So this is just easy for the eye, but don't create this amount of partitions, you will be in trouble. And this is a really nice way of joining. Probably this is already included in your primary key, so you don't have to create a new primary key. But now the question is like, when did I create row number 500? I don't know. It's an integer, and I'm collecting more and more every year, hopefully. So now the positive side is it's easy to do. It's already your primary key, no extra work. Downside, I don't know when to get rid of this. And this was a problem we faced. And then Rick came to me. Rick is a brilliant Java developer. And he said to me, can we just use a UUID v7? And, who of you knows UUIDs? I feel so stupid when I ask this question. I was researching UUIDs, and apparently the first paper about UUIDs is from the 1980s. And everybody knows them except me. I just knew they were in the list, and I had no clue what they were. So I was more like this, not like, yeah, I know this. I was more like, I don't know. Let me Google this. So what is a UUID v7? It's a 128-bit data type. And the first 48 bits of this data type is a millisecond timestamp. And because it's the leading part, it's not completely random. So if I do a lot of inserts, I still collect everything within the millisecond together. So there's not completely random I/O. And then the next 72 bits are mostly random. So within every millisecond, I can generate 2 to the power 72 individual UUIDs, which is a lot. But it's not guaranteed to be unique. So we did some easy math, and I would say we would create like 1 or 2 collisions a year for this platform. So you can't fully rely on it. You have to take care, like, yeah, maybe I create a collision. But from a practical point, it's really cool. So what happens if we do partitioning based on this UUID? Well, the problem is it looks a bit ugly, but that can be fixed. But this is basically the same as my first date partition. And if I translate my first 48 bits of my UUID to a date, this is just January 1st midnight. And I can go to February 1st midnight as well. Who did the math? Who said like 48 bits plus 72 bits is not the same as 128? Because it's not. We had another 8 bits. And these 8 bits are the version and the variant of your UUID. So that's my 7 and my 8. And the rest of my random bits I put to zeros, because I want this to be the lower boundary of my partition. And every randomness I create should be to this partition. So this is how my partitions would look like with UUIDs. And for me, to the eye, this is like impossible to read and understand. So what I do, I just include the dates in the naming of my partition. So I name my partition. This is for table A 2025-0101 till 2025-0201. So when I look at the naming, I know the boundaries. And that helps me. And now I combined the best of both worlds. Because if I look at the UUID, I know when I created it. But it's also unique enough so I can join tables together. So now I created the best of both worlds. Downside is, if your table is already there, you have to create UUIDs for all of your rows, which can be a challenge, but hey, at least you know there's a perfect solution. And then we have to talk about joining partitions, joining tables, actually. And I was working really hard to make a joke about joining tables, and then it was like, well, I don't need to joke about tables. I can just tell about joining tables, because joining tables is fun. We were joining tables on Tuesday evening here in Riga. We were sitting together with 14 people on one big table, and we accepted the fact that it's very inconvenient if the person sitting at the back in the middle needs to get for more food because everybody needs to get out. But hey, it's so much fun to join tables that that's a price we are willing to pay. But when it comes to partitioning, joining tables is more like my mom is organizing a big dinner. It's way less fun. And there's a reason for this. And multiple companies and multiple people already run into these risks. Because if you're joining tables, it's so easy to run into trouble for multiple reasons. Someone already talked about fastpath logs. I think it was Teresa. Postgres has 16 fastpath logs. So if you want to do things with your data, do something with your tables, you need to protect this data. If you're reading it, you don't want someone to truncate your table. So the first 16 logs are very fast. And if I'm just joining table 1 with table 2, I need 4 logs. Pretty easy. I need to protect my table, and I need to protect my index for both of them, so I need 4 objects. And I can easily log them with 16 fastpath logs. Now let's say I have 2 partition tables, and each of them has 20 partitions. Then I need 80 logs. I need to protect all my partitions and all the indexes on these partitions. The first 16 are fast. The other 64 have to go through the log manager, and that's just a single process organizing the logs for you. And if you're having a really pressured system with lots of concurrency and almost all your logs have to go through the log manager, you run into trouble. GitLab, I think, has a very good article about this. The problem mostly got fixed in version 18. Then the number of fastpath logs is no longer fixed at 16, so you can get more. But up to now, if you're not running 18, you can easily get into trouble with joining your partition tables. And also, when you are joining partition tables, performance will suffer. Nothing you can do about it. You can have a single table with a single index, and a single index is very efficient. If you have 20 partitions, you have to go through 20 indexes, and that by definition will take more time and more processing power than the single index. And we did some experiments with performance, and obviously I didn't know about this, and I did it wrong. And then we tried to improve on it, and the queries we did on the partition tables were 70 times faster, like 70 times faster, just by improving our partitioning strategy when it came to joining tables. So joining your partition tables correctly is extremely important. And now I'm lucky enough to tell you about it. I just wish I could tell you 2 years ago. So within Adyen, we do a lot of payments. It's still the core of the business we do, even though we do much more than payments these days. But let's say I'm collecting payment data in my payment table. And we do a lot of them, so we have to partition. We can no longer keep all of this data in a single table, so this table is partitioned. And we have to do some bookkeeping. At the end of the day, some money has to move from one bank to another, so we have to do some bookkeeping for every payment, and everybody gets a little bit of the pie. So I have payment data, and I have the bookkeeping, which I store in my ledgers. What happens if I join these tables together? Well, let's look at the most easy query we can do. I'm just selecting the payment and the ledger data for a single row. So let's say C1 is my primary key for both of these tables. And then if you look at the planner output, it's what you expect. Because I have one row for my payment, I have one row for my ledger. And the fastest way to retrieve data from something is just don't do it if you don't have to. If your data is not living in the partition, don't look at the partition. It's that easy. And when you look at this, it's like, yeah, what's the problem? Well, if you make your where clause any more complicated than this one, let's say I get 2 values. I would expect to touch 1 or 2 payment partitions and 1 or 2 ledger partitions. But what's the reality? For payment, it works. It's the first table in my query. So I go to the partition for 500, I go to the partition for 1500, and then I check all my ledgers. And it's like, why? Well, Postgres is comparing one parent table to another parent table. And if you only look at the parents, yeah, you can, there's nothing you can do, right? It's just messy, and it's like, you should be lucky that we do some trickery for you on the first table, because that saves maybe 18 partitions on the first table. But all the other joins, we check them all. But that's not efficient. So what do we need to do in order to fix this? I would say you have, no, I would not say, I will say, you have to align all your partitions around a leading figure. And you have to align all your tables around the leading figure, because if you forget one of them, it still doesn't work, and you're still paying a huge price for it. So what does a leading figure mean? Who knows this guy? Anyone from Latvia? This is Albert of Riga. He arrived here in 1201. And he's the founder of this great city. He made it a great place for trading, and he started to build of the cathedral in 1221, if I'm correct. So we have Albert, a good leader, founder of this beautiful city. And then we have Wilhelm Ostwald, who has a very German name, but he's actually from Latvia, and he won the Nobel Prize for chemistry. And he coined the term mole. Mole is one of the 7 base units in the international system of units. Do we have any US people here? Oh, too bad. I would have loved to make jokes about imperial or the how do you call all this weird millimeter mercury pressure, a gallon of a fluid? But I will skip the joke for today. Also a very good leader. And then we have this guy. He was the commander-in-chief of the Latvian War for Independence between 1980 and 1922, I think. Maybe his reputation is a bit disputable, but at least he was a very good leader and he made some brilliant victories. And also, we need a good leader when it comes to art. Mark Rothko, born here, as Marcus with a last name. I practiced for 2 days, and I'm still not confident enough to actually try it. He's from here. He moved to the US when he was 10 years. He's one of the founders of the Expressionism, the abstract Expressionism, I think I should say. But his roots were always visible in his work. So why do I talk about all these leaders? Without a good leader, you get nothing done. It gets a mess. And that's true for cities, religion, science, the military, in art. You need someone to lead the way. And again, when I go back to payments, the leading figure is a transaction. A transaction is basically the basis for any financial stuff you do. So it can be a payment, it can be bookkeeping, whatever is around. You have to take care of it. But if you're working for an insurance company, maybe your leading figure is an insured object or an insurance policy. Maybe you're working in car manufacturing, and then the leading object would be a car. But if you think about it, usually there's something in your database that connects all the data together, and you have to find it if you want to do partitioning. If you just have a little bit of data, you can join whatever you want, don't worry about it. But if you have so much data you need to do partitioning, you have to start to find your leading figure. Otherwise, it's not going to work. So let's take another look at my query, which I was unhappy about because it was doing too much work I didn't want to do. This doesn't work, right? I'm scanning all my ledger tables, but I already have my leading figure. It was my C1 column. C1 is the primary key for both. I partitioned on C1, so why doesn't this work? Well, I said you need to align your partitions around the leading figure, and this is not aligned. I have payment partitions, and I have ledger partitions. They are smaller, and there are more of them. So if I would align these partitions, it would be more like this. And of course, if you already did your partitioning, you don't want to move all your partitioning around. You don't want to say like, oh, I need to align my partition, so let me recreate everything I have. No, that's too much work, too much data moving around. That's not the way to go. But what you can do is, from today onwards, you can start aligning partitions. So you make this partition a bit smaller and this partition a bit larger, and then they have the same boundary. And from that moment onwards, you can make them equally sized, and then they're nicely aligned. Because if your partitions are nicely aligned, query performance will be much better. So if I do the same query with my 500 and 1500, I can run this, and then it's still not working. It's getting us nowhere. Why are we doing this? You just convinced me that if you align everything around your leading figure, you get better performance. And the best performance is only touch the partitions you actually need to touch, and I'm obviously not touching that. So what's going wrong here? Well, there's only one more step we have to take. There are 2 settings in Postgres, and one of them is the enable partition-wise join. And that means, like, if you would set this on by default, Postgres will no longer check individual tables, like parent-level tables to join, but it will check individual partitions if they can make a good match. But at planning time, that's a lot of work. And if you don't do your homework, you don't do the alignments, you don't do all the work to get your leading figure, That's a lot of lost processing power for no good reason at all. This only works if you do all the basic steps the correct way. But I did my homework, I checked it, I aligned it. Now I can finally run my query with this setting to on, and yes. From now onward, I'm only touching the partitions I need. And when you see a slide like this, it's like, yeah, it's easy, right? Remember the 70 times performance difference we got just because we did this right? That's a lot of time. 70 times faster queries, that's pretty cool. But we are not there yet. Because we also have transactions, and of course, a financial transaction, I also need some bookkeeping. And in order to join transactions with ledgers, I have this associative table, which means every transaction is connected to one or more transaction ledgers, and all these transaction ledgers are connected to one ledger. But I just already told you, you need to align all your tables around the same leading figure. So should I partition then transaction ledger on transaction IDs? No, that doesn't work, because then I still can't connect to my ledgers. However, no matter how I join these tables together, I always have to scan all my ledgers, and that's a disaster. So how do we fix this? And I will be honest with you, this is really hard to fix. But what you have to do is you have to denormalize your tables. That means we drop the transaction ledger, and we denormalize the ledger table, so we include transaction ID in all my ledgers. And then my data model will look like this. My ledgers will become bigger. I'm paying storage in order to get query performance. I now have way more ledgers, and a single transaction is now a one-to-n relationship to my ledgers. That means a lot of things change. The application can no longer expect this one-on-one relationship. I have multiple ledgers which are exactly the same, all of them, but the only difference is a transaction ID, which was not used to be there. So I need to change my application logic, and that's a lot of work. But again, if you want to have not too bad performance, align all your partitions around the same leading figure. And you can't make an omelette without breaking eggs, and normalization is the first egg that should break here. Sorry to tell you, it's the only way to do it. But now we can get to the fun part. It's the data lifecycle management. And before we talk about it, I think it's so important. If you're collecting so much data, you also need a strategy to get rid of this data. So what did we do together to get here? What was all the hard work we have to do? We have to find our leading figure. We have to we have to do range-based partitioning, and we have to do the alignment in the proper way. But when you do it, you're good to go. Because if you don't do it, this is how you end up. It's like, hey, can I have this PDF document from 2016? I really love to have it. And it's like, yeah, cool, let me take it. It's somewhere on this disk. Can you do some digging? And it's, yeah, I have it. It's just bad, right? You can pretend to be proud of it and have all your data in a single system. At the end of the day, it's just waste. It's slowing you down. You don't do this. So, what are we building on top of the partitioning? I have this archive database, and this archive database is completely separated from my primary database. It's a new system, and I can have huge amounts of storage, but I don't need a lot of memory here because this data I'm going to move there is all data. For some reason, I want to keep it. Maybe for compliance reasons, maybe because the application still needs this is some exceptional circumstance, but I can't delete it, so I want to keep it. But if I go to this system, this data is old, right? So it needs to come from disk anyway. I don't want to do a 100,000 queries a second on this system. So I don't need, and I can't keep a lot of data in memory here. So lots of storage, a little bit of compute, a little bit of memory, but that should do the trick. And I call it a warm storage, because I still can access this data from the application if I really want to. So what is the trickery we are going to do? Well, I just create a table, a partition in my archive with exactly the same properties. Well, maybe not exactly the same properties because I don't need to vacuum here that often and these kind of properties, but I need the same columns. And maybe I can store this in a different way. At the moment, we are using timescale and column storage to do this. So the columns are the same, but the storage type is completely different. So out of the box, we get a compression ratio for different tables, somewhere between 70 and 90%. And if you have like 100 plus databases and you get to a compression rate of 90%, that saves a lot of storage. And we have like really fancy storage, and fancy storage is just really expensive. It's the amount of money we actually really care about. It's like, hey, we need more storage. And it's like, really? Well, we can also not store the new incoming data. It's like, oh, no, okay, I buy some more. But slow it down, right? Don't spend all this thing on storage. So if I tell you, hey, we can save like 90% on disks, they love it. So I create this table with columnar storage. I can do all the compression, but now I need to move my data here. And let's say this is a partition with 1 month of data. I just start copying data, and I take my sweet time. If this is a month of data, and it takes me 20 days to copy this data, who cares? It's a month of data. At least if it doesn't take me 34 days or 35 days to copy data, I get behind. But if it takes me 20, who cares? And then when this data lives there, and of course you need to keep it in sync, but you can do something cool. I can drop my partition on the primary, I reconnect a foreign table, and I connect this with a foreign data wrapper. And this is so easy to say. Yeah, you just create a foreign table, you create a foreign data wrapper, but actually in reality, it's way more complicated than drawing an arrow on a sheet. Because what if the primary switches from one data center to another? Or how do you arrange your partitions? Not permissions. Not partitions, I should say permissions. How do you arrange the permissions on the archiving system? How do you keep track of it? So a lot of moving parts here, but it is possible. And the cool thing is, this is completely transparent to the application. And while I've been talking, we filled up another partition with data, so we can copy some more data. So again, you create a partition in your archive system, and you copy the data. And people ask me, like, how should I copy the data? And so, actually, I don't care. You can go for the BGM Kafka, you can use logical replication, you can build your own SQL, PGSQL script so you can do throttling. Pick one, and just make sure you get good at it, you practice with it, and there's one detail. At the moment you do the swapping, you don't want anything to actually work on the partition you're about to swap. So for a very brief moment, you lock the partition you're about to move with an access exclusive lock. It's like, don't even look at me, yeah? Because I'm changing stuff here. And then I can drop it, I can reattach it, and I create a foreign thing, but that's all catalog operations. So as soon as you have the lock, it only takes you, I don't know, half a millisecond to do all of this work. So what we do, actually, we don't want to ask for an access exclusive lock for a very long time, because maybe I have a query which is running for, I don't know, 500 milliseconds. I don't want to try to lock a table for half a second. So I try to get the lock quickly. If it doesn't work, I release the lock and I try again. And one day, I will get the lock, and then I can do the actual swapping. So here we have it. And now if the application needs some data, it's pretty cool. So you can go to a partition which is actually living, or the data still lives in the primary partition, or the partition in your primary system. The system is like, yeah, I have the data. There you go. And if you ask some data which is older from some old partition, the database also knows. It goes to the partition, it's like, oh, this is a foreign table, and a foreign table wrapper. But as you can imagine, this will be slower. And the downside for the application is, it's like, I don't know how to predict how fast something goes. And if I'm doing some refund on someone bought, I don't know, a car 2 years ago, I think it's reasonable to expect, like, yeah, maybe this takes a bit longer. But if you remember how complicated query planning is with all these partitions, and you have lots of them, no matter how many data you archive, the complications are still in your primary system. If I've been archiving data for 10 years, and there was one partition a year, then I still have 120 partitions. And at planning time, the database knows about all these partitions. I can run out of fastpath logs. It's complicated. So I think it's way easier to say like, all right, this is transparent to the application, it's really cool, but there is a moment this is also not going to work anymore. So you can already prepare your developers like, hey, maybe, just maybe, this system is really cool, but you run into trouble. Maybe not today, maybe not tomorrow, but next week, next month, next year, you might actually run into trouble. So let's not do this. But then it's no longer transparent to the application. No, it's not. You can't make an omelet without breaking any eggs. And if you want to have your hot data in your primary system to be very fast, maybe you should not be slowed down by some archiving system. Even though you can accept and explain like, yeah, this is old stuff, it takes longer. At the end of the day, there's someone complaining. Someone clicks a button and says like, hey, this page is loading too slow. Can't you make it faster? No. So what happens if I break all these links? Because now my primary system is like, no, January 25? Never heard of it, I don't know. But if the application knows, then, yeah, my data of March, yeah, I can go to my primary system, I can get my data there. And if I need my data from January, yeah, it lives in the archive, and these are the specs, this is the database name, the table name, the partition. And then again, this can just be a partition table in your archiving system. And this is how your entire system, with both your hot and your warm data, can be very good. And I think if you want to extend this system, maybe there's a moment in time you say like, all right, now this data, I really, really don't need it anymore. And now you can copy your data from your hot system to, I don't know, some Glacier system. And when the disk is full, you open a drawer, put the disk in, and if the, how do you call this person that comes around once a year and you have to prove everything is in order, and you can say like, yeah, there's my data. Auditor, that's the one I was looking for. So you are safe, you have all your data, but your application should not have more access to data than the data it actually needs. And that's the cool thing. So think about it. Partitioning is hard. It will slow down your queries. Maybe not today, in the first table you partition, performance goes up. Cool. If you have to partition an entire database, you have to partition it all together. Performance is going to suffer, and you should be proud of it, because it means you're doing something very well. Otherwise, you wouldn't need this system. But if you collect so much data, it also means you're collecting so much data, you should not keep it forever. So think about a strategy to delete the data, archive the data, whatever it is. But don't store more than you need, because it will slow you down. So, the summary of today. I wish I told you this 2 years ago, because it would have been easier. And the only correct way to do partitioning is range-based partitioning. That's the only way to stop your tables from growing to a size where you can't handle it anymore. It's the only way to keep maintenance under control. And range-based partitioning is the only way to join your tables together in an efficient way. So I will say range-based partitioning is the only way to do proper partitioning. And if you want to argue about it, that's perfectly fine. But I think this is the only correct way. And then the leading figure. You can't partition your database without finding your leading figure. And I know I already told you 4 times, but I really want to hammer this one home. If you are not able to find your leading figure and do all of your tables, it's just going to suffer. You need too many fastpath, or you need more logs than the fastpath logs can provide. There is no efficiency, there's no efficient pruning, not at planning time, not at runtime. It's a recipe for disaster. And yes, I know, it's a ton of work to have an existing environment which is not set up correctly, but you better start working on it while you can and while you are under pressure. Last night, I was waking up screaming. And it's like, no, it's not incident 2016 today. Because incident 2016 was around this time last year. And we messed up the partitioning. And I was looking at my CPU graph because something went wrong. And the CPU was like 60%, 70%, 80%, 90%. Hey, we have an alert. And then we were tracking back where are these 10% of CPU usage jump come from? Every time we added a partition on any table, we had a 10% CPU jump. That really freaked me out. Because I have 20 partition tables, and I know, like, if I create one more, I need 105% of CPU usage out of 100. And that's not where you want to go. And that's the real, I don't know how to explain this better. It's like if one partition on any table can create a 10% CPU jump, you know the impact on the entire system. Because we have a huge system, many tables, and if anywhere in your instance you add one more partition, you see this jump, you know in a really bad shape. So trust me, work on it while you can. And if you're proud enough to work for a company where you have so much data, you need to think about archiving, it's true. It means you're doing something very well. Or you're collecting data just because you can. But I hope no one does that, right? It's just spending money on disks you don't need. Don't collect money you don't need. Don't ever do that. I mean, now I lost the thread. So when you're collecting lots of data and you come to a stage where you really need partitioning, you need to partition well, you need to have a strategy, and you need to convince your developers, actually, to have a strategy. Because usually if you tell a developer, like, hey, this data is old, can you clean it up? And say, yeah, sure, I can. And what do? What does a developer do that needs to get rid of data? You write a cleanup job. It's like, hey, this data is old, let's delete this row, delete this one, delete this one. It's like, no, you want to have a framework in place. And we just have a configuration table for partition tables. And I tell my developer, well, actually, I force my developers to say, like, hey, this table is partitioned, and this is the moment you can throw my data away or to archive my data. You can enforce it, but prevent them from writing cleanup jobs, and then they come to you. It's like, hey, it takes me 25 hours to clean up 24 hours of data. Can you help me? It's like, yeah, I can do this with the click of a finger, and then the entire month of data is gone. It's like, really? So educate them. Talk to your developers. Tell them how important it is to do partitioning, to do data management in time, and make it easy for them. Tell them what an amazing job you can do for them to make their lives easier. They will love you for it, and everybody has a better life. So archive your data, delete your data, don't keep anything more around than you actually need. Thank you. All right, the first QR code is for feedback. Please give feedback and don't say, yeah, I loved your talk, because then I don't know what I can do better. I would love to say, like, hey, your talk was mediocre, and maybe you can improve here and here and here, and then next year I can give a better talk. So please tell me, what do you remember? Where did you get lost? Give me something I can work on, so next time I will give you a better presentation. And if you say, like, yeah, I would love to work with all these partitions and big system, and we have our own partitioning framework, because the partitioning frameworks that were already around really got us into trouble with respect to locking. So we have our own framework that has a very minimal amount of locking. We do a lot of trickery. With a lot of people will say that's illegal to do, but hey, it works like a charm. And if you think, like, yeah, that is cool, you can take a look at the second QR code. It will get you to our recruitment page, and then we can work together, because I think if we can find 10 more new colleagues this conference, we will be extremely happy. So please visit our booth, come by, and we tell you all about it. Any questions?
Thank you for the talk. So you like partitioning. What about sub-partitioning? Do you love sub-partitioning? Range, least range?
Yeah, I love partitioning. You're absolutely correct about that. I think I'm already doing pretty stupid things within my database, like creating constraints which are invalid, and then updating the catalog to make them valid so I can attach them, and all kind of trickery I should not do. So some people would say I'm brave, but I'm not brave enough to do sub-partitioning within a partition. I think I don't know what's going to happen, but I'm pretty sure it's not going to work well. But if you want to do it and like tell me about it and it works well, then I might do it.
You mentioned to find leading figures, but let's say that you pick up the wrong one and then you need to change your partition schema. Do you have any advice about how to move from one partition schema to another one?
Yeah, work hard.
Thank you.
I mean, it's a lot of data, and you need to add things, redistribute things, and it's just, if it was a little bit of data, you didn't partition it in the first place, so probably it's a lot, and you don't want to move it around. So I'm still trying to clean up the mess I created 2 years ago, and it's still not finished. So it's a lot of work.
And can you do it maybe with logical replication, like to move all your data from one to the other one and then have two different logical replications, two different partition stuff in one or the other, or that doesn't work?
Well, at the end of the day, it's just moving data from one place to another. And if I'm very honest, I think most of our crucial databases are bound by the amount of vol we can generate. So if I can prevent moving data from one place to another, I will do it, because if I have to move 100 gigabytes of data, I probably kill my system. So I just can't move it. It's sloppy, and then one moment in time I start aligning, and then when a lot of things are aligned, it's like, okay, I think my queries no longer need all this old stuff. From now onward, I can turn on the enable partition-wise join. And then sometimes you're too early or too late, and it's a lot of work still. Still trying to fix my own mess. More questions?
Thanks for the talk. How would you, or what do you consider when you choose the size of your partitions? Like how many rows do you include, or how much data?
I know it's based on nothing, but I always tell my developers, like, aim for roughly 100 gigabytes. Or if it's about log files, look at how long you want to keep them, because you can create a lot of tables, but if you create a lot and a lot and a lot of tables, you also get in trouble. So if you want to keep data for a year, I would say collect roughly 1 month of data in a partition. Then you have 12 partitions a year. I always say, like, I want to have 3 in reserve because I want to sleep well. But we also collect things for logs, and we want to keep a log around for a week. Then I create just 10 partitions, or actually a bit more because it's daily and I want to have 1 week ahead of time. So then I create daily partitions, but I can throw them away after a week. And when I say throw partitions away, I do it in 2 steps. I detach, I wait for 4 days, and then I drop them, because I created it and I make mistakes. So I give my developers 4 days to scream at me, and then I say, oh, don't worry, I still have it. But if I drop it, I have to get it back from my backup, and that's a disaster. So yeah, try to be rational about it. If I pick a partition size of an hour and I want to keep 10 years of data, it's going to be a huge amount. If you have good storage, you can have a partition of 1 terabyte, and it can be perfectly fine. Because especially if you're aligning data, and so different tables have different row sizes, right? So I have some tables with a lot of blob data. I have an opinion about it. But when my main leading figure table is 100 gigabyte, the other one is 3 terabyte, because there's so much nonsense in there. But at least if I can join it efficiently and prune it efficiently, I can live with it. So use your common sense. I think that's the best advice I can give you.
Hi, thank you for the talk. Can you legally say that you love partitioning if you don't sub-partition? Like that? No, but more seriously, what's wrong with sub-partitioning?
We started to do partitioning like 2 years ago. No, more. Maybe 3, 4 years ago. Doesn't matter. We started to do partitioning. And then you partition your first table, and it's like you go home, and it's like, I'm going to get an alert. I just don't know what the alert will be about. But something will break somewhere in the next month, because we're trying something new at a scale no one tried before. And I would say I still get into trouble often enough with 1 layer of partitioning that I don't want to go to 2 layers of partitioning. If I can run this system for, I don't know, 5 years without a single alert and not learning anything new about it anymore, maybe I will feel brave enough to take the next step. But for now, I'm being careful. I'm creating enough of a mess.
I think that's all the time we have for questions. Thank you.
Thank you very much.